Hello everyone, this is lesson 9 and today we're going to talk about digital inputs. In this lesson, you'll learn to use push buttons with digital inputs to turn an LED on and off. Pressing one button will turn the LED on, and pressing the other button will turn the LED off. Alright, so how do buttons, or otherwise known as switches, work? Switches are a really simple component compared to some of the other ones. When you press a button or flip a lever, they connect two contacts together so that electricity can flow through it. And then the little tactile switches that are used in this lesson have 4 connections, which can be a little confusing. Alright, so let's first show what the switch looks like. Alright, let's open up our camera. Okay, so this right here is the switch. You can press it like this. And then they have 4 pins that go into a breadboard like this really easily. Goes right over the canal like this, and then you can easily press it, and then it makes this satisfying click sound. Alright, so let's add a image like this, make it a little smaller. So as you can see, we labeled the pins A, B, C, D counterclockwise, and A, B are on the same side, while C, D are also on this side. So it's good to know that 2 of the sides don't have pins, while the other 2 sides have 2 pins on them. Alright, and then we can also include a diagram view of this. So like this. Again, the same pins A, B, C, D. And you can see here, A and D are connected, and B and C are connected. And even if the button isn't pressed, if the circuit does not go in between, then it only goes, for example, through A and D, then the button will be useless. You have to make sure one end is here on A or D, and the other end is on B or C. So technically, A and D are the same points, but they're just a little branched off. There are only really 2 electrical connections. Inside the switch package, pins A and D are connected together, as are B and C. So A and D are connected and B and C are connected. Alright, so this is basically all we need to know about switches. They're really simple. There's no positive or negative end. And yeah, just when you press this down, the whole circuit will be connected. And if you don't, A and D is still connected, B and C is still connected, but AD is not connected to BC. Alright, so let's get on to our lesson for today. We need to make it so that if we press one button, the LED turns on, and if we press the other button, the LED turns off. So to do that, let's include a circuit diagram. So like this. Alright, so this is our Arduino board. We connect one of the buttons, let's say button A, to digital pin 9, and then it goes through if this is pressed, then it goes into the ground. The other way is from digital pin 8, and then it can go through the button and through the ground again. If you guys still remember last class, I used a button, but we used resistors, and it was a lot more complicated than this. That's because that is a more classical way of doing things. Now the newer boards includes the resistor inside of each digital pin, and you just have to say that you're using that resistor in the setup or the pin mode function in setup. And if you don't, then it might burn the board. We'll talk about burning the board next lesson. But just know that what we did last lesson with including the pull-up resistor in front of the switch is the same as what we're doing today, circuit-wise. Yeah, and then with the two switches here, we also have an LED that wraps around the whole thing with a resistor of 220 ohms LED and goes into the ground. And then here is a breadboard view of the same diagram, like this. So button, button, LED. Alright, so let's actually make this with our own breadboard. So let's move this over, give more space for the LED, and our 220 ohm resistor for the LED. Let's do this. And other end should come here, that, and then put our LED on here. So this end is positive. Let's add this in, like so. Alright. And then we can move our Elegoo board in here, and then connect our ground into the ground here, like this. And then, so our LED is connected through the port 5. So 5 is here. And then we connect this over here to our LED. And then connect the LED back onto the ground. So like this. Back onto the ground. So now this can go through here into the resistor, into the LED, and then back through the ground. And then let's include our two switches so we can put them side by side like this. And then one of the switches is connected to 8. So over here. Like this. And then the other one is connected to 9. Like this. And then we can connect our ground lines. Just remember that this pin and this pin right here, these two pins are connected to each other. So if you want, you cannot put your ground here. You have to put it over here, like so, and then connect it to the ground. And same thing with the other one. This pin and this pin are connected, so you can't put the ground over here. You have to put it over here. All right, like this. Or you can move it up here, but I like to put it down here. Alright, so this is our circuit. This one is number 8, so this is button A, and this one is button B. A and B. Alright, and then it connects to the ground through this ground line. And then we can power the LED with this red line. Alright, so this is our circuit. And then we can write our code for this. So we can define the pins that we used. The LED pin was pin number 5. Equals 5. And then the button A pin was number 8. And the button B pin was number 9. Alright, and then we can set up in the pin mode. Pin mode for LED pin is output, and then for button A is input, button B is also input. Alright, so this is what we would do if we set up our pull-up resistor, but since we didn't actually include that into our code, so we need to add something else after input. We need to say this, we need to include this through the pull-up resistor. So we need to add a underscore and then pull up, still all capitals, and this means we need the pin to go through the pull-up resistor. Okay, so let's write that down into our code. So input pull up. So the pin mode of input pull up means that the pin is to be used as an input, but that if nothing else is connected to the input, it should be pulled up to high. In other words, the default value for the input is high, unless it is pulled low by the action of pressing the button. Default, and then this is period. Okay. So if the button is not pressed, then the input would be high, and if the button is pressed, then our input would be low. This is why these switches are connected to the ground. When a switch is pressed, it connects the input pin to the ground so that it is no longer high. Since the input is normally high and only goes low when the button is pressed, the logic is a little upside down. And then this input pull-up includes the same circuit that we laid manually last lesson with the pull-up resistor. So like last time, this needs a pull-up resistor in front of the switch. If you don't remember how it was last time, you can rewatch that video. It's only in the last example that we used it. Alright, and then this way or that way, both ways, if the switch is pressed, then our input would be low, or 0 if you will. Low is 0. And then if the switch is not pressed, then it will remain high, also known as 1 in binary. Alright, so we can include this input pull up, and then tab in the loop, we can do if digital read button A equals 0. So this means if the button is pressed, then we can write down LED pin is high, or is high. So now if button A is pressed, then our LED would be turned on, and then else if, so otherwise we can see if digital read button B is pressed. If it is pressed, then we can make the LED pin low. And then make sure the capital matches up. And then let's show our camera view. Let's plug this in. Alright, and then let's run this. Let's see. Digital right LED. So this is digital like this, and then we need to make sure that this includes a comma. Alright, now this should work. Alright, let's see. So now it turns on, and then if we press A, it stays on. But if we press B, alright, now it should work. Let's see. So it's turned on. If we press this, it's turned off. And then we can turn it on and then off like this. Alright, so this is what the lesson plan was. One of them, we can press it and it turns on. The other, if we press it, it turns off and on and off. Alright, but what if we press both of them at the same time? Then you can see it turns on because first it checks if it's if the on button is pressed, and then if it's not pressed, then we check the other one. So it would keep it on. If we don't include the else, if this is another if statement, then the light would just become dimmer instead of turning off completely. So you can see if we press both of them, okay, some of these are blocking it. Alright, so if we press both of them at the same time, it becomes dimmer. It's barely noticeable, but you can kind of see it. Alright, so right now it's turned on, and then you can press both of them like this, like this. You can see it becomes dimmer a little. It's more obvious with the naked eye, but you can still see that the light does not go through all of the case. Alright, so that's this lesson. Let's include some homework at the bottom here. So homework second. Alright, so take a picture of the breadboard with the LED set to high after completing this experiment successfully. Alright, so something like this, trying to make sure the wires don't block the LED. Alright, and before I forget, I'm gonna include this code into our lesson. this. Let's put it here. Alright, remember to complete the homework. That's it for this video. Thank you for watching and see you next time.